Hi students, in this video we're going to learn how to apply the addition formulae to solve some questions from exercise 11.3. Right, let's look at question 1. Question 1, we are asked to find the exact value for each of the following expressions. So let's do a recap on the addition formulae. Right, so the things to look out for when you're applying this addition formulae, especially for cos and tangent, it's if you look at cosine bracket A plus minus B, right, that gives you cos A cos B. But if you look at plus minus, it's no longer plus minus when you expand it. That means if you cosine bracket A plus B, that will give you cosine A cosine B minus sine A sine B instead. And if it's cosine bracket A minus B, that will give you cos A cos B plus sine A sine B. So this is the thing to look out for when you're using the addition formula. Likewise for your tangent, right? If it's tangent A plus B, that gives you tangent A plus tangent B, but the denominator will be 1 minus tangent A tangent B instead. Okay, so be very careful when you apply this addition formula to solve the problem sum. So let's look at 1a, right? So 1a, so we will get sine 60 cos 45 plus cos 60 sine 45. Right, and 60 degrees, 45 degrees, that's special angle. Right, so one way to remember the value for the special angle would be just using your calculator to help you. What do I mean by using the calculator to help you? That means instead of finding the value for sine 60, you just key into your calculator bracket sine 60 close bracket square. So you actually find the square of sine 60, which will come out to be 3/4. And because we are finding sine 60 and not square of sine 60, we need to square root 3/4. So that will give you square root 3 over square root 4, and that gives you square root 3 over 2. I do have a video on how to find values of the special angle using the calculator, so you can just refer to it. I'll do one more. For example, cosine 45. So we can just use a calculator, type in bracket cosine 45 degrees, close bracket square. The calculator will show you half. Okay, but because we're finding cosine 45, we need to square root your half. And that gives you square root 1 over square root 2. That gives you 1 over square root 2. And you rationalize it, we'll get square root 2 over 2. Okay, right. So using this method, we should be able to find the value for sine 60 to be square root 3 over 2, cosine 45 to be square root 2 over 2. Cos 60 is half times square root 2 over 2. Right, so square root 3 times square root 2 will give you square root 6. And then we just combine them into one fraction. Okay, so that is quite easy. Direct applications of the formula. For part B also, there will be direct applications of the formula. Right, the only thing here is that we're going to make 1 over square root 3 a non-fraction, so just multiply by square root 3 at the numerator, also at the denominator. So you will get square root 3 plus 1 over square root 3 minus 1. And we can't leave answer as in this form. We need to rationalize it with the conjugate surds. Right. You can just use a calculator to work this out. And then the numerator, you can just apply this algebraic identity. By now, you should be proficient in it. Okay, where you substitute the values of A to be square root 3, values of B to be 1. Alright, and then you can factorize 2 out. Or basically, you can just take 4 divided by 2 to give you 2, and then 2 divided by 2 gives you 1. But usually we don't need to write the 1 there lah. Or I think just factorize it, because sometimes you may forget to divide this 2 with this 2 here. Okay. So it's best to factorize it. So 2 divided by 2 gives you 1. That's how you get 2 plus square root 3. Okay, let's look at part C. Okay, if you're proficient managing angle in radian, that's fine. For me, I'm not too good in it, so I will convert 5 pi over 4 into degree. And that is sine 2 to 5. Cosine 30 minus cos 2 to 5 sine 30. And we need to express 2 to 5 as a reference angle. Sine 2 to 5 will be equals to negative sine 45. How do I get that? So that goes back to your ASTC. 2 to 5 is actually in the third quadrant. So therefore, this will be your reference angle. So this reference angle will be just 2 to 5 minus 180, gives you 45. And because sine ratio is negative in the third quadrant, so therefore sine 2 to 5 is equal to negative sine 45. Same explanation goes for cosine 2 to 5. Cosine 2 to 5, it's a negative value in the third quadrant, so it's equal to negative cos 45. Okay, and then you can just simplify it to get negative square root 6 plus square root 2 over 4. All right, let's go on to part D. All right, so cosine 135, it's at the second quadrant. So your reference angle will be 45 degrees. And because cosine ratio is negative in the second quadrant, so that will gives you negative cosine 45. However, sine ratio is a positive in the second quadrant, so sine 135 will just be equals to sine 45. Okay, and then you just substitute in the value for cos 45, cos 30, sine 45, sine 30, and you would get negative square root 6 minus square root 2 over 4. I think you need a bracket there. If you're going to put your negative at the numerator, you need to bracket it. Unless you're going to write it this way, where the negative is in the middle. Right, then you don't need to bracket it. Okay, let's look at E. So this is quite easy. Cosine 120 is equals to reference angle cosine 60, but cosine is negative in the second quadrant. So that explains the negative there. Gives you a negative half. And at the next slide, we will do part F, which is tangent pi over 12. All right, so tangent pi over 12 is equal to tangent 15. And 15 is not a special angle, right? So in order to find the answer, we need to express it as a combination of two special angles. So it can be 45 degrees minus 30. Right, so then tangent 45 is 1. Tangent 30 is 1 over square root 3. Right, so I'm going to multiply by square root 3 and the numerator also the denominator, so that I would end up having a non-fraction, so it's easier for me to rationalize. Okay. All right, so how about if you do not want to express it as 45 degrees minus 30 degrees? Is there another way of doing it? Yes. you can also express it as 60 degrees minus 45. Okay, so here you see that we actually end up, oh, I make a mistake here, sorry. So that's why you have to be very careful when you use the formula. Tangent A minus B, so if it's tangent A minus tangent B and 1 plus tangent A tangent B, so it's 3 plus. Okay, the next thing is I rationalize it. Which I will end up getting the same answer. But if you were to compare the steps, you'll see that the one on the right hand side involve less steps than the solution shown on the left side. So expressing 15 as 60 minus 45 gives you lesser steps. Right, so in question 4, we asked to use the addition formulae to prove the following identities. So usually for proving questions, we will just have to decide whether to work on the left-hand side or work on the right-hand side, and then try to get the answer that is supposed to be found either on the left or the right. So in this case here, I'm going to work on the left-hand side. All right, so if you're comfortable working in radian, you don't really have to change pi over 2 to 90 degrees. Right, so cosine 90 is 0 and sine 90 is 1. So that gives us sine x in the end, which is what we're supposed to find for the right hand side. So for 4b, all right, we just use the addition formulae to simplify it. Okay. All right, and cosine 90 is 0, sine 90 is 1. And that gives us cos x, which is the answer for the right hand side. All right, so for 4e, it's a bit challenging. Why challenging? Because if you were to recall, tangent 90, it's an undefined value. So if this is the case, we can't use tangent A minus tangent B over 1 plus tangent A tangent B. And so we need another method. So what is the other method that we have to use of? We have to make use of? Yes, we will have to express tangent A as sine A over cos A. So therefore, cotangent bracket pi over 2 minus x can be expressed as cosine bracket pi over 2 minus x over sine bracket pi over 2 minus x. Right, so we already managed to find the answer for cosine bracket pi over 2 minus x from 4a, which is sine x. And then you just use the addition formulae to simplify the denominator, which will work out to be cos x. And that gives us tangent x, which is what we're supposed to find on the right hand side. And that's how we do question 4. Right, so these questions require us to know which quadrants where angle A and B are supposed to lie on, so that we can draw the right angle triangle correctly. Wrong, so that we can draw the right angle triangle at the correct quadrants. All right, so you're given A is obtuse. So obtuse angle is one that is more than 90 less and less than 180. So that will be in the second quadrant. And for tangent A to be negative under your ASTC, so tangent negative will be in the second and the fourth quadrants. Right, so then the intersecting quadrants will be at the second quadrant for angle A. All right, so now let's look at angle B. Angle B is between 180 and 270. That will be in the third quadrant. And for tangent to be a positive value, that will happen under the ASTC, that will happen in the first and the third quadrants. So the intersecting quadrants will be the third one. So with this information, we can now draw the right angle triangle at the correct quadrants. Let's start with angle B first at the third quadrant. So tangent ratio will be the value from the opposite side over the adjacent side. So that will be negative 15 because it's below the x-axis, and negative 8 is on the left-hand side of your y-axis. All right, so to find your hypo, basically you just bracket negative 8 squared plus bracket negative 15 squared, and that will give you an exact value, which is 17. Okay, so let's go on to draw the diagram for angle A, which is in the second quadrant. All right, so in this case here, we can't use a calculator to work it out because you end up getting an irrational number. So you will have to do it without using the calculator. And this will gives you 16 plus 25, and that gives you square root 41. All right, so with all these informations, we can just go on to find part I. Just use the formula sine A cos B minus cos A sine B. Just find sine A, from the diagram that indicates angle A. That will be 4 over square root 41. Cos B will be negative 8 over 17. Cos A will be negative 5 over square root 41. Sine B will be negative 15 over 17. All right. So rationalize it, you will get negative 107 square root 41 over 697. That's for part I. So part 2, just use the formula correctly. All right, plug in the correct informations. Simplify again, rationalize it. All right, so part 3. Okay, so part 3 is easy. You don't really need the diagram because tangent A, basically you're given as negative 4/5. Tangent B is 15 over 8. You can just plug in the value, and then you can just use your calculator to work it out. You will get 107 over 20. All right, so for question 7, we're asked to solve the following equations. Solving the equations means to find the values of x that satisfy the equation. So we're just going to compare your cos x, cos 3x minus sin x, sin 3x with cos A, cos B minus sin A, sin B. And you'll see that we can actually substitute your angle A with x and the angle B with 3x. Right, so what we're actually solving is cos bracket x plus 3x equals to 0, which actually we are solving cos 4x equals to 0. All right, so the range given should be for x should be between 0 and 2 pi inclusive. And because you're given 4x, so we need to find the answer to find the new range, which is between 0 and 8 pi. All right, so if you recall your cosine curve, right, cosine 90 will give you 0, and cosine 90 and cosine 270. Okay, if you recall, if you cannot remember, just go back and revise on the cosine curve. Cosine 90 will be 0, cosine 270 will be 90. Cosine 270 will be 0. So let's start off with cosine 90 first. So therefore, 4x, first answer will be pi over 2. And then you need to add 2 pi to get the second round, 2 pi to get the first round. Oh, sorry, second round. 4 pi to get the third round, and then so on and so forth. So actually this answer is rejected. Never mind, you just continue doing until we just we can always reject the answer at the last step. Right, so divide all the answers by 4 to get the value of x. Yeah, so the last answer is out of range. because 17 pi divided by 2 will be 2 point something. The range given, it's up to 2 pi only, so we have to reject 17 pi over 8. All right, so that's the answer for 90 degrees, but we know that cosine 270, which is cosine 3 pi over 2, will also give you 0. Okay, and then divide by 4 throughout. And you see the last two answers, it's out of the range, so we just reject it. Okay, there's a typo error here. This answer, it's 3 over 2 pi plus 6 pi is actually answer for 15 pi over 8. So only the last answer is rejected. Okay, so that's how you solve 7a. Let's look at 7b now. Okay, 7b likewise compare sine 2x cos x minus cos 2x sine x with sine a cos b minus cos a sine b. So that means we're actually substituting a with 2x and b with x. So we're actually solving for sine x equals to 3, square root 3 over 2. So the reference angle will be sine inverse square root 3 over 2, which is pi over 3, special angle. And for sine to be positive, it will happen in the first and the second quadrant. So x will be equals to alpha, first quadrant. Second quadrant will be pi minus pi over 3. Right, so for 7b is easier than 7a. Right, so for question 10, you're given that a and b are acute angles such that cosine bracket a minus b equals to 4/5 and sine a sine b equals to 1/5. And we're asked to find the exact value of cos a cos b, cos bracket a plus b, and cotangent a cotangent b. Actually, this is quite an easy question. Why is it easy? Because if you basically you just need to apply the addition formulae for this, and also the addition formulae for part 2. Right, so that's what we're going to do now. And you're going to substitute the values for sine a sine b to be 1/5. And from there, you can find cos a cos b to be 3/5. And that will be the answer for part I, right? So for part 2, again, we're going to use the addition formulae to evaluate cosine bracket a plus b to get 2/5, right? So that's what I mean by is quite manageable. So for part 3, cotangent a cotangent b, so basically you must know that we can actually write cotangent a as cos a over cos a over sine a, and then cotangent b as cos b over sine b. Right, and that will gives you 3/5 divided by 1/5 because we have already found the values of cos a cos b in part I. Sine a sine b is given in the questions to be 1/5, so that will gives you 3/5 divided by 1/5, give you 3. Right, so that's part 3. So the only difficult part probably it's the last part here where you need to explain why is it that the questions, the conditions that a and b are acute must be specified. So to answer the questions, think of it this way. If a and b are not acute, if a and b are something else, then would your condition still hold? So let's say if your sine a is positive and your sine b is negative, then would you still get sine a sine b equals to 1/5? Yeah, you won't, right? You won't get sine a sine b equals to 1/5. So therefore the questions need to specify the conditions for a and b. If they're both acute, then positive times positive will give you positive, right? If one of them is negative, then you would end up getting a positive value. Right, so hence, yeah, the conditions that A and B are acute has to be specified in the questions. Right, let's look at the second last questions. It's not difficult also. Right, we're asked to do some proving in part I, and then part 2 is to show that hence means we have to make use of the answer that we have found in the first part to show that cotangent 75 degrees is 2 minus square root 3. This is quite similar to the O-level questions, right? the kind of questions that you may see in the exam now. All right. Okay. So let's do some recap. Right. So cotangent A is 1 over tangent A. So therefore cotangent bracket 45 degrees plus A is 1 over tangent bracket 45 degrees plus A. Okay, I need to remind you folks that I actually have encountered some answers, some folks writing cotangent bracket 45 degrees plus A as written as what I've shown you. Okay, so in this case here, this is not the correct way of presenting it. This is not correct. If you're confused how to write it, I'm just going to show you. I'm just going to let 45 degrees plus A to be the letter B, okay? So what you're getting is cotangent B, which is basically 1 over tangent B, right? And if you're going to replace back your B with 45 degrees, can you see that the correct way of writing will be what I have shown you here? This is the correct way of writing, okay? The one in red is the wrong way of writing. So please do learn the correct way of expressing it. Okay, I'm going to erase off all this. Excuse me. Okay, so let's continue. Right, so basically I'm taking 1 divide by this whole chunk of thing. So I need to flip it to get 1 minus tangent 45 times tangent A over tangent 45 plus tangent A. And tangent 45, it's 1. Okay, then how do I go on to prove what I'm supposed to be, how do I prove to be getting cotangent? Because what I have here is tangent A, right? So it's actually quite easy. The trick is just to multiply by cotangent A at the numerator, also at the denominator. Basically, you just multiply by 1 over tangent A at the numerator, also at the denominator. And you see what happened. Okay, you see that 1 times this will give you 1 over tangent A, and tangent A times 1 over tangent A will give you 1, right? And then you just express your 1 over tangent A as cotangent A. And that's it. And that's what you're supposed to prove, what you're supposed to get for the right-hand side. All right, so how do we make use of this answer to find cotangent 75? Right, so if you do a comparison, 75 with 45 plus A, basically what we can do is we're just going to substitute your A to be 30, because 45 plus 30 will give you 75. So you just substitute your angle A here with 30 degrees. That will give you the answer for cotangent 75. Okay, so the explanation is there. Compare cotangent 75 with cotangent 45 degree plus A. So substitute A to be 30 degrees. And cotangent 30 is 1 over 30. 1 over tangent 30. Tangent 30 is a special angle, which is 1 over square root 3. So 1 divided by 1 over square root 3 will just give you square root 3. Okay, so the explanation is there. And we need to rationalize it with the conjugate surds. All right, and apply some algebra there. Okay, square root 3 times square root 3 will give you 3. Okay, and then basically you just apply this algebraic identity. Or minus. Okay, so that will give you 3 minus 2 times AB plus 1 squared, which is 1. Okay, and this is just your A plus B times A minus B gives you A squared minus B squared, or you can just use your calculator to evaluate to get 2. And then you can factorize your 2, because that will give you 4 plus 4 minus 2 square root 3 divided by 2. So that gives you 2 minus square root 3, which is what the questions require you to show. Right, let's come to the last question. Question 17. So you're given the cosine bracket x minus y equals to 4 over 7, and cosine x cosine y equals to 3 over 7, and you're given that x and y are both in the first quadrants. Between 0 and 90 degrees means they are in the first quadrants, are basically acute angles. Okay, without using a calculator, ask to find the values for tangent x, tangent y plus 1 for part I. Part 2 is sine squared x minus bracket sine x cos y close bracket squared. Okay, and then you're supposed to explain what happens if your angle x and y are no longer in the first quadrants, but they are in the fourth quadrants. So would your answer change? All right, so let's do a recap first. Right, so the addition formulae for cosine bracket a minus b, that will give you cos a cos b plus sine a sine b. Why do you want to recap that? Because we want to evaluate this one that's given in the questions. Right, and we're going to substitute sine cos x cos y to be 3 over 7 because it's given in the questions, to find sine x sine y. So this question is a bit similar to the one that we've done earlier, similar in terms of applications. So with the values for sine x sine y and cos x cos y, we can just plug into part I. Right, so the takeaway is that you need to know that tangent x can be written as sine x over cos x. Okay, because without the knowledge, then you would not be able to continue. So that's the takeaway for part I. Okay, so for part 2, what do we do? Right, so for part 2, we have to square sine x cos y to give you sine square x cos square y. And then you see that sine square x is a common factor where we can extract it out. And this one will require you to apply the knowledge of trigo identities. Right, if you were to remember, one is sine squared y plus cos squared y. Sine squared y plus cos squared y equals to 1. So therefore, 1 minus cos squared y is equals to sine squared y. So replacing 1 minus cos squared y with sine squared y, right, we'll end up getting this. And then we can just make it as a perfect square. And sine x sine y, we found it earlier on to be 1 over 7. So that will give you 1 over 7 times 1 over 7 gives you 1 over 49. All right, and then what happens if your angle is no longer in the first two quadrants? In the first quadrant, not first two, in the first quadrant, but rather in the fourth quadrant. Will the answer change? Right, so if your x and y are in the fourth quadrants under your ASTC, cosine is positive in the fourth quadrant. So the value for cosine x and the value for cosine y would be positive, which makes this positive also and make cos x times cos y also positive. So both of these conditions will still be valid. So hence, the answers to both parts of the questions will remain the same. All right, so that's all for this video.